Hey everyone, I wanted to run through the Mathematica notebook with you for the syntax for MATLAB 2. First off, how you compute partials, you use the big D notation. Your function goes here, and then the variable that you want to take a partial with respect to goes there. So this is the function partial x, and if I hit Shift Enter, it cranks out 2x for me as expected. For partial y, you just change this x to a y. This is going to give me partial y, I get 2y. You can do more than one partial. You just list off the variables if you want to do like a second order partial. So this is first partial x and then partial x again. And we expect what, 2. And here's a mixed partial. I can do partial x and then partial y. So that's how you do it. I want to show you an error that you might run into if you have already defined x, maybe x equals 1, and we say y is 2, and then you go back and you try to do the partials. You get this craziness, like it's thinking x is 1 and y is 2. So if you get something like that, you need to go ahead and clear your variable. So you just say, make a new cell and say capital clear x, run that, and then you can say capital clear y and run that. And now if you run it again, it's going to work. So I'm going to erase this stuff here because I don't want it to be messy. But that's an error that you may run into. Okay. Sometimes a lot of the problems we do, I think it's easiest to define your function. So to do that, you can call it f or g or h. It's your variable underscore, comma, variable underscore, square bracket, colon equals, list it out. When you're multiplying, Mathematica interprets x, y with no space as a new variable. So you've got to either put a space or, even better, the ampersand for times. So just be careful with that. Here's my function. I'm going to run it. It's got it, and now I can take the partial derivative of that function with respect to like the second order partial f y y. This is the notation, and you can crank it out and it'll give it to you. So notice that something did change. We kicked out a negative here, right? It is, we expect this partial to be sort of repetitive. The only thing that's really happening is the derivative, that there's only a 1y on the inside, so nothing's really going on. If we do like xx, then we're going to have to do a product rule, and we expect it to get kind of nasty, and so you can see the difference there. Okay, so that's that. I should change this, otherwise when I save it, it's not going to match up to what I'm saying it is. So, there we go. Okay, so that's how you do partials. It's really straightforward. I'm also going to ask you to graph a function with its tangent line at a specific point. So what I want to show you how to do here is how to label each piece and do them one by one and then graph them all together at the end. So the problem that we're going to do in this quick example video is I want to find the tangent plane to this function at the point 1, 1/2. So I'm going to define my function g. I'm going to run my coordinate axes so that those are defined. And the first thing I'm going to do, well, I guess piece 1 is the coordinate axes in your function, yeah. The second thing I'm going to do is actually graph the surface itself. And the key to making this step by step is to go ahead and label your graph. So I'm using S1, S for surface, and you're going to have two problems. So you'll do an S1 and then later you'll do an S2 for the second surface. So S1 equals, and then this is just the graph. This is the equation for the graph. You guys have already done this. So contour plot. I've already defined G. I don't want to retype it, so I just say Z equals G of X, Y. I only do the underscores when I'm defining the function. So I can run this, and it gives me the graph. There it is. This is not my end result. I don't even need to see the graph right now. I'm going to put it all together later, but you can look at it if you want to. All right, so now piece 3 is find the tangent plane. You've already defined G. We have Mathematica can take the partials for us. So here I'm telling Mathematica, look, compute partial x of G. Then this syntax allows you to plug in the point. So you can copy this and then change it to your function, and it'll do it for you. But if I want the value of the partial derivative of G with respect to x at this point, I get 3. Here's the partial derivative with respect to y, I get 5/8. And then I want to actually get the z value of my point. I wasn't given that, so I plug in 1 and 1/2, and I get z is 5/4. And so just following the formula that we learned in class, right? Your tangent line is 3 f partial x times x minus the x coordinate plus 5/8, that's f partial y, times y minus the y coordinate, minus 1 or minus z minus the value of the function at your point. So this 5/4 is this the g of 1, 1/2. equals 0. That's the equation for the plane. I want to graph it and label it. So I'm going to label the tangent plane T1. So I say T1 equals, and then my graph, and then I typed it in. The only thing you have to remember is in the contour plot, you need a double equals. So the way I typed it here, I had 1 equals, put a double equals there. And then copy this code. When you do your tangent planes, copy this code and drop it in on the end. This really cleans it up, and it's going to turn it blue, and it's going to also make it a little bit clear so we can see the whole picture better. So let's run that, and we get the plane by itself. Again, the goal here is to put it all together at the end, but we're labeling things as we go. So there's my tangent plane. Now I want to actually graph the point. I want to see the dot where the point is. So copy this code. I'm going to call it P1 for point 1. And you just copy this. I'm making it red. You can change the color if you want. You can change red to blue or pink, or there's lots of options. You can feel free to modify the point size. But the point is, the point in 3 spaces, 1, 1/2, 5/4. The 5/4 here is just g of 1/2. So you can check that if you want. G of 1/2, and you get 5/4. So that's what's going there. So run that. It'll graph the little point for you. Again, by itself, great, but that's not really helpful. Now, at the end, you put them all together. So you just type in show, and then you type in the names of all your graphics. So coordinate axes, the surface, the tangent plane, and then the point that we're interested in. And if you run this, it all combines into a really nice graphic where you can see the point, the surface, the coordinate axes, the tangent plane. There it is. That's how you do it. So I'll ask you to do 2 of these, and so just a reminder, you'll want to go through and call your first graphics S1, T1, P1, and then your second graphics S2, T2, and P2. All right, so the syntax is posted on Teams as well as the problems. I hope this helps.